The level
Is it-
surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
I'm not kidding.
Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well,
sound level.
Is he not frequent? Do you not? Oh, I thought you all got together. All you Globe Defender heroes. You know, like your weekly, bi-weekly, or monthly. I don't know. However you might do it. I always imagined you had like a lair where you all go together. Fight the flat earth, looking on his big chair at the top of you, looking down on you all. I need you all to defend my new geometry. What do you think is going to happen to the horizontal that you establish with the water level?
I'm not sure that water levels can establish a horizontal.
Are you saying that when they measure, they measure things using Euclidean geometry, and then you can just think of that straight line that you measured a horizontal distance, and you can then transform it somehow into your mind into a geodesic, which is also a straight line, but you can think of it as though it curves somehow? Would that be more akin to what you do?
But geodetic surveyors do obviously use geodesics and obviously use non-Euclidean geometry.
Just like they use non-Euclidean geometry.
Geodetic surveyors? Yeah, I believe so.
Do they? Wow. So they just take Euclidean geometry, dimensions and angles and all of that, and they convert it into non-Euclidean geometry?
I'm not sure that they do that. I know Jesse. Actually, I learned how to do that from Jesse's vlog. I said at one point that a water level is not a useful tool to finding a horizontal. I did say that.
You know, Bev said he hoped he didn't. What did you say, Bev?
I hope it didn't trigger him too much last night. I mean, Rumpus came in and had to run away, and he took him ages to come in. So yeah. I think I saw you in the chat.
Chat, yeah, I was typing in the chat. That's the only reason I popped into Ranty's. Somebody was using my picture, and that Andy was. That's right. No, I wasn't triggered. It was interesting to listen to Ranty's show.
Do you listen to that often?
Make it really quiet for me. Say again.
What, if you've not turned me down, have you?
Oh, turned all the way up.
Okay. Does that sound all right for you, Emma? I don't want to be turning myself up too much.
It sounds all right. I think. Do you want to turn your camera off, Bev? Because I think DP's having trouble getting in.
Okay.
You sound just fine, Bev.
Yeah, you sound fine.
That's right.
Yeah, you do.
So yeah, I hope we didn't trigger you too much. Because we just had to leave you here, didn't we? While we were doing that. Because we were having that discussion where you had parallel lines intersecting. Just in the show that we went to go and do a thing about parallel lines, it was. Yeah, we had to leave you hanging. Sorry about that.
It's fine. I left around the same time. But no, I never got to express. Well, I expressed it to Jeremy later, but I never the whole thing with you guys. I never got a chance to, so I'm not sure that I said what you think I said.
You said parallel lines start off parallel and then end up intersecting. That's pretty much what you said, wasn't it?
You cut out for a second, but I can already tell by the way you started, and no, it's not what I said. I don't know if you remember or not, but I never got the opportunity to speak full sentence. try to explain it, but eventually when I saw Jeremy later, I could explain it in about 2 seconds.
What?
But all I was saying was that lines that would behave as if they were parallel, as they should in Euclidean geometry. For instance, if you have perpendicular lines, like geodesics, on another line, so they're perpendicular on this line, they would behave as if they were parallel if it was Euclidean geometry, because they're both perpendicular on the same line. However, in non-Euclidean geometry, they immediately start to converge towards each other. So even though you're starting them out as if they should be parallel, they don't end up being parallel.
So they're straight lines then, or not straight lines?
Well,
Like,
they're geodesics.
Do you get confused? Yeah, it's a straight line, right?
Well, I mean, you can think of it as a straight line, but it's called something different for a reason.
You call it a geodesic, but it is a straight line. It's the shortest point between the shortest path between 2 points.
Okay.
Yeah. I mean, I would agree with that. It's a straight line. That is what a straight line is. Now, when you're presuming to just change geometries like that, are you saying that when they measure, they measure things using Euclidean geometry, and then you can just think of that straight line that you measured a horizontal distance, and you can then transform it somehow into your mind into a geodesic, which is also a straight line, but you can think of it as though it curves somehow? Would that be more akin to what you're doing?
But geodetic surveyors do obviously use geodesics and obviously use non-Euclidean geometry.
Just like they use non-Euclidean geometry.
Geodetic surveyors? Yeah, I believe so.
Do they? Wow. So they just take Euclidean geometry dimensions and angles and all of that, and they convert it into non-Euclidean geometry?
I'm not sure that they do that. I know Jesse. Actually, I learned how to do that from Jesse's vlog, or blog, I guess.
Jesse's vlog.
It's actually pretty easy to do that.
Who's that? Jesse? Who's Jesse? Jesse who?
Sorry, I'm typing something out. Give me a second.
Jesse Ventura. Somebody's vlog. It must be really important, right? If he's got a vlog. Jesse's vlog.
Yeah, Jesse's.
I learned it from Jesse's vlog. I mean,
yeah. Plus, with a name like that, it must be very important.
Jesse, yeah. That sounds like an official title or something.
It's called Jesse's vlog, but it's really Koshos.
Nobody seems to know this Jesse. He disappeared. Are you sure we've got the right Jesse that we're talking about? Koshos.
Sorry, I'm just reading something.
Okay, you were writing something before. Reading and writing. This Jesse, who's this Jesse we're talking about, and his vlog where you learned to switch geometries, was it? Jesse's vlog about geometry switching.
How to convert from non-Euclidean coordinates to Euclidean coordinates as well.
Non-Euclidean coordinates to... Wow. Go on then. Where Jesse who, please? You typing or you were searching? Are we putting it in the debate discussion?
I forgot his last name. What's his last name?
So, Right, so when they measure a distance, a horizontal distance in a straight line, and they have that distance, because that's what happens in reality, that's what they do, right, then why do they need to convert it? Like, how do they do that with the other geometry? How does that work? What happens to the straight line that they've just measured once they plug it into the geometry? Does the straight line change or anything? Do you reckon?
No.
Do you reckon we
But
could
the only
bend
real
that straight line in reality because you do a bit of geometry switching?
yeah, the only real application I personally would use it for is converting the coordinates in a GPS system, because they use Euclidean geometry and then we read it in non-Euclidean coordinates.
Okay.
So
Okay, so would that do anything to the horizontal that you're establishing within a water level? You know, that equilibrium point that's reached when a water equalizes.
transferring from one of these systems to the other wouldn't change anything about the world.
Okay.
It's just a way of reading.
So when they say it's the water level is a tool for establishing a horizontal plane of reference, what would you imagine that to be then? Like, if you know the geometry or changing the geometry doesn't change anything at all, then what do you think is going to happen to the horizontal that you establish with the water level?
I'm not sure that water levels can establish a horizontal. I know you've asked a surveyor and who said that.
No, it's not when we've gone a bit past that. Ask a surveyor, right? Because obviously you've only got 3, haven't you? And like one of them isn't a surveyor, definitely. George, I'm talking about George Nutsack. He's like definitely not a surveyor. You've got Jeff, who can't seem to notice that he's got different horizontals when he makes a video about setting tools up. So that's not much use if you've got a surveyor that can't notice and even makes a video showing that he's got different horizontals by different tools set at the same level point, right? They were about 10 foot away from each other. You've got another dude who's disappeared. And then Larry Scott, who just trolls about on YouTube, and he won't even come and talk to us about any of this. They're the only ones you've got, Kosho. That's it. All of the other countless surveyors that we talk to say that level is horizontal. It's fundamental to their job. And you can't deny that the water level would establish a level, right? What there is at one end of the water level is at the other end. It levels, it equalises out. You've only got 2 points. Draw a straight line between them.
That lighter now.
Did you just have one?
Yeah, whoever put the fucking lighter? Fuck that, it's like bright yellow. Where the fuck is it gone? It's like a luminous yellow. Oh, there it is. Down the back, down there. Oh, I do need it, wee.
All we're going with is what we know from reality, Kosho. That's it. Is that something at the door? Robin? Oh.
Can you hear me, Bev?
I can now.
Yeah, that's cool.
Oh, DP's back.
Yeah.
Hello.
Send me a message, tell me to turn my camera off.
Who did?
No, I said next time you can't get in or it's not working.
Yeah,
Oh,
no,
right.
that's why I said turn it off, and then I changed the server as well. But I think it's just
No,
Discord and your
I think it's
internet.
a problem at my end as well. Yeah.
Well, if you've got weather like we have here, it's absolutely pissing it down.
Yeah, it was all right earlier. It was nice and
Alright,
clear
yeah.
earlier, but
It's
horrible now.
been non-stop rain since I woke up.
It was a bit shitty earlier.
And it's dark as well. It's horrible. Bring back the sun.
Yeah, I know.
So I don't know what Kosho did. Kosho just sort of stop answering questions when they got a bit tough. Is that what's happened?
Yeah. Did you ask me that question? I was doing some laundry.
All right.
I was waiting for an answer from you, Koshos. So.
Answer?
You were writing first, then you were looking at something, and then you decided to do some laundry.
Yeah.
Yeah.
Yeah, Bev asked you
You
about
ever do things?
the number of surveyors that you have.
I don't think I have any surveyors.
That you rely on for information.
I don't think I rely on any surveyors for information.
So you don't know what you're talking about. Then?
Just some Jesse's got a vlog somewhere that you've read, and that's your main source for how you can swap geometries and affect reality somehow.
Why would you assume
that's what we've
why would
got.
you assume that?
Because water level establishes a horizontal plane of reference. That's known, and it's industry standard. That's what level is. Now, you said you've read a vlog somewhere from some guy called Jesse, somewhere on the internet, that has told you how you can transpose coordinates from Euclidean geometry to non-Euclidean geometry. I then asked you what difference that would make to reality, and you said none at all. So, how, once again, we go back to it. What sources have you got for saying that level isn't horizontal?
So you said about 4 different things there. I'm not sure how they're related. But the transformation from non-Euclidean to Euclidean, I got from, I guess I read something on Jesse's thing, and then I ended up reading it on Wikipedia to get the equations.
Jesse's thing.
So you could
It
say
was a
Wikipedia
vlog.
was
Jesse's vlog. Who's Jesse?
Of course, I got that from.
Jesse Ventura.
And the question you asked at the end seemed unrelated to all the other things you said, which was about horizontal and level, which wasn't anything that anybody said. I said at one point that a water level is not a useful tool to finding a horizontal. I did say that, but I didn't say anything about level being or not being horizontal.
Oh, nicely obfuscated. So you didn't actually say anything then at all, did you?
No, I told you that I got these off Wikipedia. Then I told you that I've said that. I mean, I haven't said anything about level and horizontal. But
Did somebody say stop mentioning Jesse to you? Did you get a memo just then? Like, who's Jesse? Who's this Jesse that you're reading vlogs from that tell you that, what was it? Was it that straight lines can be transposed from one geometry to another? Is that what this Jesse's vlog taught you how to do?
I read this on Wikipedia.
Oh, just on Wikipedia?
To the blog.
Yeah, the equations weren't on his blog, no, but the method was.
Have you got a link to the blog?
The equations are pretty simple, so.
Very kosher. Can you give us a link to the blog?
You can find it on Walter Bislin's website.
Oh, Walter Bislin.
Can't you just link
he called
us to the
Jesse?
blog?
Is that what is that Jesse's vlog? The one that Walter Bislin, does Walter Bislin go under the pseudonym of Jesse?
Uh-oh.
Walter Bislin made that model for Jesse, didn't he? On Rakier, like for Life's Bridge.
Did you figure out who Jesse was?
No, I don't know. Jesse, you said Jesse. That's all you've got. Some dude called Jesse that you've read a vlog for that can teach you how to transpose different coordinates from geometry to a different geometry that won't affect anything in reality anyway. But I mean, hey, let's talk about that shit, right? It's much better than actually talking about a level being horizontal, isn't it? If you can talk about some dude's vlog that's can transpose coordinates from one geometry to the other. Some dude called Jesse.
I mean, how to have conversations, man. But I've made another picture with the identifiers, and it shows you how
made another picture.
At the 80-degree point, there's a horizontal, and at the 60-degree point, there's a horizontal.
Oh, there's horizontals intersecting, right?
Those are both locally horizontal.
They're not. Neither of them are horizontal. If you look at
the 4 or 5 posts
either of them are
all posts from a water level.
Neither.
Those water levels are not going to make a horizontal.
Neither or neither. Horizontal. No, because they're not water levels. The water would piss out of them, wouldn't it? You couldn't actually put water in them and get them to stay level, because that obviously that wouldn't be a horizontal way. I mean, you could freeze them, I suppose, but that wouldn't be a water level then, would it? It needs to be a fluid. Liquid at rest, I think it is.
Water level is the blue post. That,
just on a side note, Bev, did you
up.
see this yesterday?
It's not loading up. That's
it's just
link.
copied the link.
Yeah.
Hang on.
Put the LTP.
Message link. There we go. Find that one. It's just a link.
It's the same thing again.
Oh, jeez. Media link. Try that one.
Fucking LTP.
Oh.
Might put it on a t-shirt. What do you reckon?
Yeah, unicorn sphere.
What do you reckon, Koshos? On a t-shirt?
I like those little divisions that you've got. It's almost as if it's the way of dividing that up for angles or whatever from the central point.
You might get a lollipop for that.
Might get a lollipop for it. Koshos, where's your sense of fun? Where's your sense of adventure?
Lollipops are fun. Not sure where the adventure comes in, but yeah, those are the spherical coordinates we were trying to go over with you guys yesterday.
They look like different angles.
Have you noticed
There's one radial line and 2 angles.
There's a North Pole on it, no South Pole.
Radial lines, yeah, that's how to do angles, right? We did do that yesterday as well, didn't we?
Yeah, but many of you guys didn't figure it out. You just threw eyeballs on it.
It's not often that we get to go over that sort of thing with angles. How to explain what an angle is to somebody. Have you ever done the triangle thing with us? Because when you're measuring horizontal distances and making a triangle, like if you have 3 straight sides, because that's how you measure an angle, right, between 2 straight lines, and then if you have 3 of those, the best shape you can make is a triangle, and it always has 180 degrees internal angles. It's really weird, that, isn't it?
Weird. It's also not true.
What? A triangle without 180 degrees?
The triangles they measure on Earth have more than 180 degrees. That's why they call it
Sorry?
spherical axis.
Sorry?
Spherical axis.
It's straight.
Axis.
Yeah, a triangle with straight lines.
They make a triangle. They make several
Yeah, straight lines.
angles and several triangles.
Yeah. You measure an angle between one point and another point. I mean, that makes a straight line to make an angle. And then you have three angles, a triangle, and you add them up and you get 180 degrees. It's fantastic geometry like that. You don't...
It just turns out when you do it on Earth, though, you don't get 180 degrees.
What? You measure a triangle with straight line sighted distances, sighted angles, and you don't have 180 degrees.
Yeah, I would have thought you might have heard of this before.
Oh, I've heard of people like imagining a triangle with more than 180 degrees, right? But have you? Who told you that?
I mean, I've seen this.
Wasn't on Jesse's vlog, was it?
No, I've seen it plenty of places though. I can show you.
Fight the Flat Earth. I've seen Fight the Flat Earth. That he's got some papers. Have you got them from Fight the Flat Earth? Maybe Mactoon. He has a website, doesn't he, where he goes IP fishing for people's IP addresses, right? And then he finds out where they're from. But yeah, he's got a website. Have you got it from there? I bet you've got a tab open right now, haven't you? Try it. See if that's where you've got your information from. Jesse's vlog. That reminds me of a little song that. And it was that. Jesse's Girl, wasn't it?
I think so, yeah.
Jesse's vlog.
That's
There
it.
you go.
I wanna be in Jesse's vlog.
Like Jesse's vlog.
Yeah, I have no idea what they're on about.
Bit before your time, maybe.
Yeah.
Yeah,
Us-
oldies.
Us old men.
You're not that much older than me.
To be honest, it's before my time.
Yeah.
Before mine.
You're a
I know.
fetus. You don't count.
Fetus.
What about Jesse paint the picture about Jesse paint your picture?
Oh, good God,
Oh, yeah.
no.
No, I can't harmonise with that one. Come on. Come on, Kosho. Who is this man? Who is the mysterious Jesse with the vlog?
You need to make a wanted poster.
Yeah.
Yeah.
Have you seen
Jesse
this
wanted.
Jesse?
Yeah, but we don't have a face to put to the name. do we?
Kosho
We've
just
got this
keeps saying Jesse,
Just
the
put a silhouette.
mysterious Jesse.
Yes.
Who is this man that writes vlogs?
I might put a silhouette of Beeloo.
Yeah. So, and Walter as well. There's a connection there to Walter.
Tell me if you can see this. Hold on. No, you're not gonna be able to see that. Yeah, I'm trying to load this publication, but it's too big, I think.
And the
Let's see how
American
big it is.
arc of the parallel.
Yeah. Right. So, a triangulation, when they make a triangle, right, and measure angles with a triangle, straight lines, right?
There's no need for bendy triangles.
Is there? I mean, it's got to be, because in order to have three angles, you have the inclination
Dad.
of two straight lines. Yeah, go on.
Well, just thinking, like, when if you explain it like like the mountaintop, that's a good way of trying to.
Well, yeah, I think we did that. I mean, that's what obviously.
Kosho. Like in real life, I mean, because
Well, that's where they
too
are.
much.
Oh, this triangulation is the transcontinental triangulation of the Arc of the Planet. That's what they did. They sent dudes up mountains with mirrors and theodolites and stuff, and the guy measured. He looked at one and he did the other one, right? Because triangles are the only shapes you can do trigonometry with.
Isn't that all line of sight though?
What?
If you're going up a mountain and looking at one mountain top, from one mountain top to the next mountain top, that's all line of sight, surely.
Yeah, line of sight, straight lines. I mean, that's what the tools, the theodolite measures an angle from one point to another, and that means it's a straight line.
So, Kosho, tell me, how do you get your claimed spherical axis from measured straight lines from the tops of mountains?
I was able to load it there. So yeah, if you open that,
I think Jesse might be doing some coordinate conversions.
All in there.
You called it.
It's a pretty long one though.
How'd you do it, Coach?
Oh look, you did go to McToon. Oh, that's nice. I'm not pressing that. We can't go to them links. I'm not doing that.
Yeah, I've never been there before.
Hold on, Kosho. 2 seconds, please.
So you found that? Wait a minute. You found that McToon thing because I told you about it.
That's right.
Right. So you literally have done research on it within the few seconds since I told you about it, and now you are going to cite that bullshit.
I have the same publication. I just can't load it because you can only do 8 megabytes on your system.
Okay, nice to know where you got it from.
So they got it from McToon.
Yeah. So that's another site. McToon is the site that you have to go to. He's your source.
Yes,
brilliant. Okay, there you go.
I had this publication. He didn't write this at all.
Okay, carry on, Spot on. I'm going to nip into the toilet.
Well, all I was going to say is that I inquired about. I said to you about these lines from mountaintops when they mapped it, and DP's just asked Kosho as well, and I think that needs answering because we can't continue if he doesn't understand that basic understanding. Then where we just continuing. There's no point. So yeah. Do you mind asking that again, please?
Me?
Yeah, man.
Right, Kosho. You got straight lines measured from mountain tops. Line of sight.
Is he listening? That's the thing, though, or is he looking at what he's doing?
I doubt if he's listening at all. How do you get your claimed spherical axis from straight measured lines and angles?
So I take it you're just not aware of how this works at all?
Stop obfuscating and answer the question.
I have to know how much you understand about this before
I understand that you need 2 straight lines to form an angle. You are claiming spherical excess in a triangle through optically measured straight lines. Now, how do you get spherical excess in a triangle through lines that are measured optically with straight lines?
Right. So I guess, as I said, you're not really aware of how this works.
This is what I'm asking you, Coach.
You point at one target.
This is what I'm asking. This is exactly.
You point your sights at one target. That way, let's say you're 100 miles apart, and you point it at one target, and all that you're wanting to do is match it to its vertical of that target to make sure that you're angled horizontally, so that you may not be pointed directly at it, but you're pointed at its vertical column.
Its vertical column. You're pointing at an optic tool at the vertical column. What vertical column, Kosho?
So you do this to another column as well.
What
so you have
vertical
2
column,
positions.
Kosho?
Right. So you have 2 positions. One, some other distance away. That'd be, let's call your position A, and there'll be B and C. And so you'll want to point your sight at B and then point it at C.
Point
As I said, you're
it
not
at what
concerned with
at
perfectly
B and
matching it
C,
up
Kosho?
horizontally,
What
but
are you
you want to make
pointing?
sure it's vertically
Kosho,
aligned with that.
listen to me,
And then all you're
Kosho.
doing is measuring
Stop
that angle.
talking, Kosho, and listen to
No,
me.
no, no, no.
What
I'm
are
not gonna
you?
do that. I'm not gonna play
What
that
are
game with
you
you. If you're gonna ask me a
pointing
question, I'm
at?
gonna answer the question,
What
and
are
then
you
you're gonna stop
pointing
talking.
at B and
But
C? What vertical column are you pointing at?
yeah, so we're not gonna play this game. That was your one. That was your one.
You claimed a
one
vertical
shot.
column, Kosho. What is a vertical column when it comes to surveying distances?
He'll be researching it right now. Go and check it up. Ask
Just explain-
McToons.
just explain
Kosho,
in full.
go and ask
I just
McToons what he
explained the
would say.
entire thing in full. And
Go
if
and
you
say
missed out,
DP's asked me
that's
what's a vertical. What should I say? What should I say, McToons?
Do you know, I've never heard so little said with so many words. It's amazing. Have you got an answer to the vertical column question yet, Kosho? So you can still do it. Oh, yes, do. To see you. Are you still here, Spot on?
Oh, yeah, I am.
Hello?
So I'm
Did
working,
you-
but,
Did the show's ability? Do you feel you have had your knowledge enhanced through his answer?
I'd like him to explain again the actual real life representation of what he's talking about, and then we can just understand how he's curvature within a straight line.
Are you in the east wing? Spot on. I'm clipping a bit, mate.
It would be nice to hear about.
Do you not feel fulfilled through that explanation? Okay, be honest. You can be honest.
I think these computer models, I quite like them. Who does all of your computer graphics modelling for you, Kosho? Do you do it?
That's Google SketchUp, isn't it?
Who is it that does that? Because I mean, they look like would they be Euclidean triangles that you've got there drawn?
I've made this bit.
Mm-hmm. You made it. So you've got. So are they actually 46, 46, and 91 degrees then in that triangle?
That's what it says.
I know that's what it says, but I mean, in actuality.
I look at straight lines to me, but that 46.
You see the way that it seems to be two different triangles there, Kosho, right? It doesn't, like when they meet up, it doesn't even look like a... Like, there is two different triangles there, isn't there? I mean, it almost looks like a Bridge of Asses, right? You seen that? I think it's a postulate... proposition 4, sorry, not postulate. There isn't 4 postulates in my book. There's only 3.
from the position that's closest to front of the picture, there's 2 horizontals from that position.
Horizontals? The ones that are pointing
One
up in the
pointed
air?
to the first target, and one pointed towards the second target.
Yeah, the ones that are pointing up in the air. That X. It's like, wait, what? You know, when we do horizontals, right? It's like an even altitude. It doesn't matter what's underneath them. I never would bother drawing the shape of anything underneath the horizontal level. That, you know, I can't imagine why you keep doing that. You put it on a ball. Why is it you do that? Because you say you draw a horizontal of a nice... It's nice graphics and all of that. I like the dude that's doing... It's a bit grey and dull. Make it yellow and black next time. But why do you always have them pointing up? Like, they're never actually horizontal, although you call them horizontal. And you always put them on top of a ball or a circle. What's that about? You're into balancing things. But balancing things at funny angles.
I spilled it, Del. I spilled it.
I used that program in school.
Did you?
Yeah. Google SketchUp.
Who's the Google sketch? Oh, you did that, right? So you know when you've got, like, it shows that there's 3 angles there, but see how many lines there actually are. It's hard to tell which triangle's which there. You've got that many lines going all over the place. What's that meant to signify? Kosho.
Just a moment.
It's just some different angles. Because it's not like a triangle, that is it? That shape. Would you call that the shape of triangle?
It's got another point at the top that you're not even measuring.
It's got a couple crossing over here,
Yeah.
right? And then it's also got this line here that's different than this line here where the angle is here. Like, I don't know what this line's coming off here as well. And then look, you've got another line here. We've not got a clue. There seems to be 1, 2, 3, 4, 5, 6. 6 lines there, Kosho. Should we go and have a look in Euclid? I don't think we need to, do we, for the definitions of a trilateral figure. I think that's what they call them. Of which triangles are the most prominent. In fact, they're the only ones, really, aren't they? You can't make any other shapes with 3 sides. 3 straight sides, 3 angles adding up to 180 degrees. But it isn't really, it's just 180. It's 2 right angles. Half of the 4 right angles that have to be equal. All right angles are equal. I do love these geometry lessons, Kosho. They're great.
Here's another. The same fucking picture, just
Okay.
one
Well,
different side.
I'm more interested in for you showing us a triangle, right, with 3 straight sides, as though you're obviously viewing something with more than 100, more or less. What was it?
Okay, more.
Is it more?
More than
More.
180.
Well, I'd say you can't have more or less. You have to have 180 degrees in a triangle. It's right. It's 2 right angles, right?
See from this one, it's vertical, straight up and down. Those 2 lines are the horizontal lines made from that position, pointed towards the other 2 positions.
Because there is actually, you can do 3 lines, right? You do. It's sort of got something to do with the parallel and the perpendicular, right?
Smack on this.
Koshos. Yeah, you should switch the
What is it? Is
thing
it
on.
video? Yeah.
So that's the way spherical axis works. It points from one position, gets an angle from looking at the other two positions, then from the second position, it'll do the same thing, points it at the other two positions. And then
You know
again,
much
from the
about
third
proofs, Kosho?
And what they'll do is they'll measure only the horizontal angle.
See, look.
And you add those together, and you get the spherical axis.
I'll draw
Yeah,
this.
we still didn't get what we're measuring against. Kosho.
There you go. See that? That's 90 degrees there. Right, now, this line has got to join up to this line here, right? But if we do this, we've got that. Now, can you see that?
So it's like a right angle.
Yeah, so that's two right angles, and they call them 90, don't they? 90 there, and 90 there. Now, what else do we know about? Oh, that's right, isn't it? It's the 12th axiom, the one that you don't like. Looks very much like this, but basically it says that the sum of the right angles have to be less than 182, less than the sum of two right angles. Otherwise, they don't meet ever. They call them parallel lines. Right, so that 90 plus 90 is 180. That's why it has to be less than 180. Otherwise, these lines will never meet. And if these lines never meet, you can't have three-sided shape with either less than 180 degrees or more. It's freaky. Really, really weird, Kosho. How do you explain that now then?
Well, I just got done explaining it. Of course, it's on a sphere, so I'm not sure why you're using Euclid's postulates.
Okay, so we're not using Euclidean geometry and because this is the basis of angles, and a triangle is this becomes the hypotenuse because it's a right angled triangle, and you do the three sides. That's why 180 degrees in a triangle, and now you can use a triangle to measure the sides in relation to the angle. So you don't want to use that.
Sorry, use what?
Nice. The Euclidean geometry. You don't want to use it. It's okay.
Well, it's not that I don't want to use this. It's not applicable on the surface of the sphere. So.
But surveyors, well. So if surveyors use Euclidean geometry, then where do you think that would leave you with your? It's not applicable on the surface of a sphere. What do you reckon that would do? Would you be able to come to any sort of conclusion?
Explain to me how surveyors do spherical excess. Because this is a tool.
Sorry, you want me to explain to you how you can have a triangle with more than 180 degrees, when that is the question that I've been asking you all
I'm just explaining
along.
to you how they find it, and you're still asking me how they find it. So
you
you
tell me how they find it. You tell me.
I just did that.
How?
I'd done that twice.
How?
I'm not doing it a third time, but I've done it twice now. I've shown you the pictures of the description I've given, and you're still asking me how it's done.
I'm not asking you how it's done because I know you haven't got a clue how it's done.
Even though I've just mapped it out for you and shown you.
You haven't. Like
the method that they do it and
anybody else that's in this room, has anybody else heard Kosho explain how they measure more than 180 degrees?
he said something about measuring to a post from... No, I haven't. No. From tops of mountains, 100-mile away, was it, Kosho? But he didn't actually say how.
Right, we're gonna do this plan. We're gonna get the boys out. You wanna go mountain surveying, lads?
Oh yeah, go on. Come on, DP. We're going mountain surveying.
Yeah.
Let's
You
go.
can have a mountain.
Yes.
So there we go.
Is this a day out?
What? Yeah. What? You can have a red mountain and a purple mountain and a green mountain, and we'll draw blue lines. So, green mountain. Pointy. You there.
Yes. No.
And purple mountain. DP. Do you wanna? Where's DP gone?
Purple.
Oh, it's falling off.
Purple.
Oh no.
A bit of fluff. He picked up a bit of fluff. And red mountain.
Emelo.
Emelo.
Doesn't
Come
catch
on. Boom. Emelo. Right. So, we've got Yoda here, and he's looking at, they call this DP's mountain. DP's mountain, and this is Emelo. Emelo. Yoda mountain.
Yes.
Right, so Yoda looks from here. Have I got anything to do? So Yoda's on his mountain, and you've all got your, what did he call it? What did Thingy call it? Kosho. What's this called? This vertical thing. Post. Is it a post? Kosho. What are we citing? We're citing
Vertical column.
vertical column. Right, so everybody's got a vertical column there, and they've all got their own vertical column. Now,
Because we were listening to what he was saying.
yeah.
What's the
I don't think
column
he's
made
listening to
of?
what we're saying.
Right, so we draw a line from here to his vertical column, and then we're going to, obviously, because we're going to turn and sight our angle from Yoda to there. So Yoda's going to make this angle here. This is Yoda's angle.
Yeah.
A yangle.
Yeah.
Yangle.
Yeah.
Yangle with the dangle.
Now DP as well. He's going to make his angle.
Dangle. Is it make his angle?
Is it dangle?
Yeah.
My
The-
dangle angle.
Yeah, DP angle.
The
And
monkey's
obviously-
dangle angle.
Emma is going to do the same because she's just going to look through hers at Yoda's and DP. She's going to size up the angle between Yoda and so they're all doing that. And
Does
this
Emma
is
have a dangle?
here is the Emelo angle. Right now, when you add up the angle from Yoda, DP, and Emelo, anyone any ideas? Kosho, what do you reckon you get? We don't think we need to put a distance between them, but I mean, let's do that. It's 100 miles. Whoa, good shit. Got some good scopes.
Yeah, fucking social distancing.
Yeah, and there's another 100 miles. And then this one's all very conveniently spaced mountains. But you can do that when you make shit up, can't you, Kosho?
I was going to say, one that making equilateral.
Well, yeah. What do you reckon? Depends how high it is as well, doesn't it? Let's say, let's put them all massive mountains, 10 metres. 10 metres above sea level, right?
I don't think Kosho's listening.
He is, he's listening. Of course he is. That's why he comes here for the geometry lesson.
You listening, Kosho?
So, I'd say when we add all of these angles up, because we're making a triangle in between all of the points, 180 degrees. Wouldn't you? I would. Anyone else?
No, I'd agree.
I could have a better go than that. A triangle with sides of 1, 1 and 1, look. You can even guess what the angles would be.
100, 100, 100.
Yeah. We could guess what those angles would be, couldn't we, Bev?
60.
Well, I mean, this actually is the first thing of Euclid. Shout out. Proposition number 1. Hello. Equilateral triangle.
How many?
Well, that's easy. You to know which half the angle is, because we know that the triangle has 180 degrees, and all of these sides are equal. And if the sides are equal, because triangles are fantastic like this, then the angles are equal. It's like a like a logical relationship between all of this stuff. When you think about it, I don't know. It's uncanny how it just sort of logically seems to fit together. That yeah. I mean, yeah, I think you'd have to be a bit weird to go like, well, nah.
540, innit?
What I think what Koshos wants to be able to do in this fight the flat Earth geometry that they're making up is this: if these sides get bigger, then the angles get bigger. Is that right, Koshos? Is that what happens? We have a triangle that starts off with 180 degrees at, I don't know, local, on the page, on the paper. And then as you extend the lines, the internal angles start increasing. Right, Koshos?
Sorry, just stepped away. What would you say?
Would that be right? If we have a triangle with 100 miles, do you think we could still have 180 degrees in the middle? Do you think that would be allowed? Or not?
Yeah, indeed. Yeah.
Okay. So increasing the length of these sides does nothing to the amount of angles within inside a triangle.
I mean, I guess first you'd have to learn which angles you're measuring, which I guess you've neglected to do.
Yeah, angle from Yoda. Yoda's looking at DP. Emilo. Emilo's looking at Yoda to DP. They're all on top of their little mountains. 10 metres, little mountains, you don't get big mountains.
No.
DP's scared of heights.
You're just strictly using the horizontal. So.
No. Well, I mean, we could. Emilo could go up a big, like this one here. He's like a, whoa, 1,000 metre, 10,000 metres.
Fucking daring.
Yeah. You want to see the lungs? Sorry, Emma.
That's a rare old pair of lungs, that is.
But that would still make a triangle with 180 degrees, right? Because that's a straight line. And that's a straight line. And that's a straight line. Because they're sighting angles. They're just measuring an angle from one point to another. See this here? This is how you measure an angle. So these straight lines, the radial lines going outwards. There you go. Look, there's an angle. So from that there's 10 degrees. But it's obviously it's bigger there than it is down here. But as you go out further, it increases more. It gets bigger and bigger. But it's still the angle between the two straight lines that come out from the radius, right? So that's what an angle is. I mean, we did have, who did we have the other night? ICQ.
Yeah.
ACQ. So did you get that, Kosho? Because when you're making your new Fight the Flat Earth geometry to help him out with this stuff, with the bendy straight lines and intersecting parallel lines and all of that, you can have a Kangle. I think that was what we wanted, was it? I think he's decided to call it a Sangle, but he wanted a C. I'm not so sure it works like that, but yeah, so that's an angle to a curve. But if you have like this here, you have a straight line and then a curve like this, like a circle. Hey up. So where would you measure the angle? Like here, because if you measure the angle there, there's nothing there. How do you work that, Kosho, with an angle to a curve? I think you need two straight lines to measure the angle in between. I would say an angle to a curve. I don't think that would work at all. So, first of all, you'd have to define an angle to a curve. Otherwise, you're talking about the angle between two straight lines, as far as I know.
Oh, it's another picture for you.
Wow,
Like I
posting
said, the
pictures.
angle doesn't come from the triangle that you've made from the observers. It comes from the horizontal angle only. The horizontal, I guess if you think about a theodolite, for example, it's got the two axes.
Is it in
Really
there?
looking
Yeah.
at the horizontal axes.
So what's the elevation of your mountains to get over the hump that's in between the two people?
Well, so where's your angle? Your angle. Let me have a look. Can you put it on there?
Yeah, on live stream. Not that one.
No, he's in the debate discussion. He's not allowed in the live stream. It's Kosho, isn't it?
Okay, so he's posted two.
Okay, so like this. Oh, look at that.
Hey.
Oh, that looks.
Similar, right?
Oh,
there.
hey,
Come on.
Kosho, you like that? So where's the angle? Oh, that's right. The angle is a projection of this bit from inside, isn't it? There.
Yeah, so it's bringing.
Yeah,
that
Kosho?
out.
It's a projection of this. This section on the inside. Straight lines. Right? Ah, so that's where you get your angle from. You get your angle from the straight lines on the inside.
They're on the surface there.
No, the angles are on the... You need the straight lines on the inside. On the inside of this bit. Yeah.
That wouldn't make much sense
They're not on
in
the
reality.
surface.
They're not on the surface. The surface is a curved. Look, can you see all the way that curve is all the way around?
You're bringing it up off the surface.
Yeah, you're
measure those
extending
three
that.
angles.
You're extending these lines from the inside, from in there.
Yeah, so you're making them
But
straight
beyond,
lines.
you just extending that out beyond these bits. It's pretty easy to see how you've done that.
Yeah.
Well, in the image I've shown you, it shows you how you have three observers. You make a triangle.
This
would
one
make
here, look.
80 degrees.
Put somebody on
Then
this
you
end
use
of
the
the line here.
horizontal
We'll
component.
put someone on this end
They
of the
give you
line.
500.
What can you see? Can you see this other guy? No? Oh, you can't see my finger, eh? What's that mean? You can't. How do you see it for line of sight, for angle of measurement, if you can't see what you're looking at, Kosho? What are you talking about?
Wouldn't choose a place that you can't see. That would be pretty stupid. That might be something you would try.
So you
but
would
reality,
make sure you
they
can see
find
something.
mountains
So
where
then
they
you
can
would be using a straight line. You wouldn't need a curve. Again, you're imagining a ball
don't use
underneath
curves
a
for
straight line.
Yeah, curves aren't used for this. You make straight lines.
Yeah, of course you
make
do.
straight lines from
You
you to
have
the
to.
observer, and then you measure the horizontal component
Yeah.
of your measurements.
Horizontal. Yeah. Horizontal.
gives
Set
you-
by the water
That
level.
gives you the red lines I've shown you on the.
No. They're
image.
curved lines.
Yeah, but you don't need curved lines. You just need the straight line
Yeah.
from you to the observer.
And the straight lines for the
horizontal
angles.
component.
You need the straight lines for the angles and the straight line horizontal for actually measuring a vertical distance, and straight lines for measuring angles, and the horizontal and the vertical. The difference between them two, yeah. There's no need for any curves.
It's an image I've shown you, so I'm not sure what part you don't understand about it. But the observers are on the straight lines. The sights they're making are the straight lines from them to the other observer.
See, look, here's the straight
Then what
line,
they do
look.
is they use only the horizontal component, which is going to give them what those red lines are doing on the ground.
Look how
So
far
those
away
red
that is
lines
from the
are
red
gonna
line.
Are going to find the triangle that they're
Miles off.
measuring, and that's where they'll get their spherical axis.
Miles off. Look at that. You can't make this straight line bend round here.
And you've chosen not to
it's
understand it.
It's
So
only horizontal there, isn't it? I mean, that's not horizontal. And that's not horizontal either. You can't think that's horizontal just because I've put a ball there.
you can get it wrong as many times as you need to get it wrong, man. I've already shown
I'm not
you
getting this wrong.
horizontal lines. I've shown you
No.
two images. I've shown you the one I've made.
This
and the
isn't
one that I
horizontal
found
because it's on a ball.
of horizontal lines.
No, this is horizontal here.
See, my images aren't doing the things
That's
that you're
horizontal.
doing.
This is a straight
That's the
line and this
problem.
is a curved surface of a ball, sphere. It's a curved surface, right? You might be getting confused with your two-dimensional spherical geometry. Right? Because, I mean, this obviously isn't two-dimensional, is it? That's three-dimensional surface. Curves away from every point on it. You'd need a, what do you call it, a straight, flat plane. Mathematics for a two-dimensional surface, right? So, in order to measure an angle, you need a plane and the inclination between one straight line and another based around the center point. There's
Give
your,
them the tools to learn,
there's
man.
your 90 degrees.
Decide
See
to
that?
use them or not.
90 degrees, that. And then you put it in there. Right? So this is just like an eighth. It's a slice. You slice the ball that way, halfway through there, and then you cut a quarter out of it, like a cake, and that's it.
What practical application does
That's
that
it.
have to carve a hole in the
It
earth?
doesn't have any.
Right, it doesn't have any, so I'm not sure why
No,
you're
it
showing
just
that.
to show geometry, right? To show people that in order to measure these angles here, you have to cut into the surface and use the straight line angles between the straight lines inside it. Because you can't do it from the surface. You can't measure an angle from a curve to a curve. Because there's no straight lines on the surface of a sphere.
Since I've
None.
already explained
None
to
at
you
all.
how you do that. I've shown you several times how to do it, and I've
No,
explained to you several times.
Kosho, you can't show me how to do it. It's
I've just showed you several
impossible. It's
It's
okay.
impossible, yet it's done.
It's okay. But yeah,
People do it all the time. So
not by
people are
random
able
dudes in
to
Discord,
simply
right?
Figure
Yeah.
out the thing I've just
See, look.
to cut a hole in
This,
the earth.
these aren't straight lines on the surface of a sphere. You can't have a straight line on the surface of a sphere.
Yeah, which lines do you make to measure those lines? Are they
What?
the straight
To
lines
measure
that I've
them?
showed you? The white lines in the picture right there? Yeah,
What?
those are the
You
lines that
use
you.
those-
Those are
they're-
the lines that
They're
you
not
create.
these lines, though, are they? They're straight lines.
Yeah, that's not. Yeah, the way you measure those lines from those two lines you've
The
made is by
angle.
looking at the horizontal component.
The
You
angle.
don't look at the entire angle.
The angle,
You look at
yes.
the
You
horizontal
measure the
component.
angle in between the surface here to this surface here, which is what your picture shows, Kosho. Exactly what your
pretend
picture
to know
shows. That's
whole
why
bunch
I
of
made
stuff.
this model, to show people
know-
that you need
very-
the straight lines from inside.
You know very little about surveying, Bev.
What you're showing me a thing of a sphere like this, and then telling me about surveying. I'm not talking about surveying here. I'm talking about geometry and how you measure an angle and how you cannot measure an angle to a curve. You want to talk about surveying? I'll put the ball down, because nobody surveys a fucking ball. What are we talking about, Kosho? Do you want to talk about geometry and the angles on a surface of a sphere? Or do you want to talk about surveying that you also seem to know absolutely nothing about?
Taught you about spherical excesses, which is a tool that surveys.
With these triangles with more than 180 degrees. Is that what you're talking about?
Like I said, it just seems to be news to you for some reason, since you seem to know more about.
I'll say it again. A triangle with more than 180 degrees is impossible. Now, what do you want to tell me about triangles with more than 180 degrees?
I mean, I've already told it to you and shown it to you and explained to you how you make straight lines to measure them, and you look at the horizontal component. You whatsoever, and you'll pretend that I've never said it. So, what's the point?
I'll pretend that you've never said. I mean, I'll remember forever that you've said that triangles have more than 180 degrees.
I'll remember that one as well.
Yeah.
But mind you, it's not the first time he said it. So.
Very brave of you. You're standing up for Jem. Jem said that first. He was one of the first ones that I thought I'd ever hear saying it. And of course, Fight the Flat Earthers said it, and Team Septic. Who's the other one? PhD Tony. Who else? I mean, it's a bit special. PhD Tony says you can have a triangle with 540 degrees. Can you imagine that? You must have seen the video. Kosho. Have you got a video of Vsauce finding out? You're going to check that. Don't be watching PhD Tony talking about it, right? Can you imagine how to have a triangle with 540 degrees? Are you checking with MacToon?
What about MacToon?
Yeah. He's Scottish, you know.
My day started.
Scottish. Roots. That's why I call him MacToon.
Yeah, I've never spoken to this person.
You've never spoken to... Is he not frequent? Do you not? Oh, I thought you all got together. All you Globe Defender heroes. You know, like your weekly, bi-weekly, or monthly. I don't know. However you might do it. I always imagined you had like a lair where you all go together. Fight the Flat Earth looking on his big chair at the top of you, looking down on you all. I need you all to defend my new geometry. And Koshos, they're like, oh yeah, I can do that. I'll do that for you.
How old is non-Euclidean geometry, to your knowledge? Is it new?
Yeah, well, about 19, what do you reckon? 50, when did they start, do you reckon?
Like 200 or 300 years ago.
Oh, that long?
It's not very new, is it?
Is that when they started to phase out Euclidean geometry then?
Why would they phase it out?
Oh. So all of the relationships with triangles for measuring lines and all of that still stand? And like you said earlier, you can do a transformation within coordinates, but doesn't affect reality at all, does it?
No, I don't know why it would change reality, the ways you're interpreting it. You're just choosing to interpret it in one way or another.
Well, triangles and Pythagorean theorem and trigonometry and all of that are pretty vital about the length of the side and the relationship between the length of the side and the angles.
Yeah,
You know that trigonometry and cos, sin, tan, all of that sort of shit. You know remember that when you did that thing and you labelled that line cos.
Planar triangles, yes.
Yeah.
Planar
Well, not like
triangles
that, like actual trigonometry, right?
Spherical triangles do not behave the same way. I think you know that.
Okay. So, well, like that's what I said. So, when do you throw out the Euclidean geometry? When did that happen?
Throw it out ever.
Okay.
Which again, I'm not sure.
So spherical triangles don't act the same as Euclidean triangles, and they still use Euclidean triangles. But you can just imagine it, do a coordinate transference or something afterwards.
You're trying to figure out the angles of a
it.
triangle on a piece of paper. You would use Euclidean geometry. If you're trying to figure it out on an ellipsoid, you would use the non-Euclidean geometry.
But if you were sighting with the theodolite, you would be measuring straight line angles from point to point, right? You would be using Euclidean geometry, wouldn't you? Now surely you wouldn't take that measurements and all of them and then do some sort of fantastic transformation to try and transform reality into a new type of reality that you want it to be. I mean, that would seem a bit much, wouldn't it?
Theodolite, no. That's why theodolites have limits. It's because those limits are expressing the limits in which you can use Euclidean geometry to describe it. When you use non-Euclidean geometry, you'll need to do something else, like the spherical axis, as I've shown you.
Okay, so is there a limit to Euclidean geometry? Does Euclidean geometry happen within a local? Like, could you call it? Is there any distance you can give us that might be able to falsify hydrostatics, straight lines being straight and parallel lines staying parallel? Is there some sort of a distance? I hate to say scale because I don't think you understand what a scale is. So can you just give us a distance where straight lines stay straight and horizontal lines stay horizontal and level, and parallel lines don't intersect, and then the point at which you have to swap to a different geometry in order to get all of those things to occur, like straight lines bending and parallel lines intersecting and triangles having more than 180 degrees? Please. Googling McToons. Oh, yeah. Has he gone?
Yeah.
Oh, I thought we were just going to find some really good information out then.
Oh, thank fuck for that.
I just put in the text chat, he's doing my balls in.
Oh, I've just been zoned out waiting for him to fuck off.